Dear colleagues, welcome back again. So now in this video I'm going to talk about flowchart. Let me start. So in the last video I talked about algorithm. After you created algorithm, you can prepare a piece of code to be able to understand as a human beings, and this piece of code is called pseudocode, human readable code. In other words, it's not going to be enough to be able to write in program, write in editor, and then run the program. That's why you must just prepare pseudocode for your let's say human readable part. After you prepare the pseudocode, the good thing is that we are using a flowchart. So flowchart is having some graphical shapes, and then this shape is just, they have some meanings. With that meanings, it's very easy to see all the flows of the program. And here are the main shapes that we are using for the flowcharts. The first one is input and output shape, which is parallelogram. The other one is for the processing steps, for the calculations, addition, multiplication, or assignment, whatever it is processing steps for the rectangle, or vice versa. Rectangle is for the processing steps. And the next one is for the decision, for the if statement. We are using a diamond shape to be able to control the decision. And the other one is that arrow that is just showing the how flow goes, starting the program and ending the program. The most important thing here for the flowcharts, I'm just explaining like this. In the start part, we are just filling up with the water. This water must follow the arrows. After the arrow finish, after the water achieves to arrive to end, your flowchart is successfully has been done. That's why that's important. The next part for the flowchart, here is an example to make a sandwich. In our real life, we are using algorithm and of course flowchart, as you see from the previous video I told you. And here start has water, as I mentioned, and it's just getting the bread, as you see that parallelogram, and these are the inputs. You can read it simply. And then here we have processes, and at the end we are having the output, and our water just moves into end. So this flows all boxes and then coming to end. This water flows all the boxes and coming to end. So like this, if we just carry on another example, which is like numerical example, as you see, you are just getting Fahrenheit temperature to convert Celsius degree, and then here is the box for the process. You're just making calculations, showing the output, and at the end. So this is like simple one, and you can have the other ones later on. You can just pause the video and just read through yourself. Here is another one. Pause the video and read yourself. The next one is, which is nice one, find the minimum and maximum of the two numbers. And here is the in start. In start we do have our water. Water comes to here. It's for the input, number 1 and number 2. If number 1 less than number 2, there are two possibilities, yes or no. So for the diamond shape, for the decision, 1 entrance, 2 exit. I'm repeating, 1 entrance, 2 exits. So it's very important, and to show that exits, yes or no, true or false, 1 or 0, T or F. So whatever it is, at the end of the day, there should be like two possibilities, which is going for the true, the other line is going for the false. So 1 entrance, 2 exit. So after you enter with your number 1 and number 2, you are checking is number 1 less than number 2. This is the question. Is number 1 less than number 2? If it is yes, your flow, your water is going to go this side. If it is no, your water is going to go this side. So let's see, number 1, number 2. If number 1 is less than number 2, yes, then minimum is going to be number 1, maximum is going to be number 2. Then follow the arrow and print the minimum, maximum, print the result, and end. Your water achieved to come here to end. Another way, is number 1 less than number 2? No, it is not less than number 2. If it is not less than number 2, then what does it mean? Your minimum is number 2, your maximum is number 1. And then print, and then comes to end. So somehow, for example, you forget to put all those parts. Let's say somehow you forget, sorry, right, not you, I forget, I didn't put. What will happen? For example, number 1 and number 2, user enters here, 5 and 10. Is 5 less than 10? Yes. What will happen? Water will stuck here, it will not go this side because there is no program here. So your program is not properly has been done. Your program is working for something. For what? For example, your number 1 is 10, your number 2 is 5. Is 10 less than 5? No. Okay, correct. And coming here, minimum is going to be number 2, which is 5, maximum is number 1, which is 10, and result 5 and 10. Correct. Your program is running for this kind of condition. But what about, as I mentioned, 5 and 10? If number 1 is 5 and number 2 is 10, 5 is less than 10, correct, but there is no program for this one. That's why you must think about your, as I mentioned, your flows. You must think about your water to visit all the lines and come to end. It is very important part. Now I have another question. Flowchart, for example, computing minimum of the 3 numbers. If there are 3 numbers and you would like to find the minimum of them. First of all, here start has liquid water, coming back here, and here you are going to collect number 1, number 2, and number 3 from the user. After you get those information, is number 1 less than number 2? Yes. If it is yes, coming here. So think about it. Number 1 less than number 2, and you coming yes. Here you are going to have, is number 1 less than number 3? Yes. If it is yes, definitely and absolutely that number 1 is going to be the smallest number. Minimum is going to be number 1. Let's come back here. Is number 1 less than number 2? Yes. And coming back here. Is number 1 less than number 3? No. What does it mean? Number 3 is less than number 1, and number 1 already less than number 2. So minimum going to be number 3 because it is no. Like this, if you follow the other ones, as you see, yes, no, and then you put everything, and then if you put water here, depending on what you enter here as a number 1, number 2, number 3, your water can follow from here or from here, or it flows from here to here, or flows from here to here, and at the end you are just printing as an output minimum and showing to the end. So this is called flowchart. So this flowchart, by using one of my friends program, I draw here, and it's very simply showing you how to calculate how it runs. And I must test maybe all of them, but I will test a few of them. I did test already. Let me clear out. For example, we are here in the start button, and you can see it's like blue color around, and then step by step I will carry on. When you click step, as you see, from here to here it moved. We are here as an input. Number 1, it's asking number 1 step. Here is the input area. In this input area, I'm just going to enter now a value, for example 2. When you press enter, as you see in the output area, number 1 is going to be 2. So after number 1 is 2, it's just moving to here. So it's also input for number 2. I'm just entering a value for number 2, let's say 5. When you press enter, as you see, number 2 is 5. After that, it moves from here, that liquid, that water moves from here to number 3. We are in number 3 now. So what is number 3? Let's say it is 10. When you press enter, number 3 is 10. So as you see in the output part, number 1 is 2, number 2 is 5, number 3 is 10. So we have all those 3 numbers, and then next step is condition. We are going to check, is number 1 less than number 2? If it is yes, so it's going to come this side. If it is no, it's going to go this side. So is number 1 less than number 2? Let us check. Yes, 2 is less than 5. Then if 2 is less than 5, if number 1 less than number 2, then it moves here. Let's see, it's going to move there. Yes, definitely it moves. That water moves from here and here. Run this part. What is this? Number 1 is less than number 3. Let us check. Is number 1 less than number 3? 2 is less than 10. So definitely after that, what's going to happen is going to move this side. Minimum is going to be number 1. Let's see. Yes. And after that, it's going to move this one to here. Minimum is going to be shown on the screen. As you see, 2 shown on the output, and program ends. Program is working properly. But of course, we must just visit the other ones by giving some other examples. Okay, so we are in start now. For example, number 1 is going to be 6. Next step. Number 2 is going to be, let's say, 4. Next step. Number 3 is going to be 5. As you see, this time 6, 4, 5, number 2. The previous one, number 1 was shown as 2, but this time number 2, which is 4, is going to be shown on the screen. But let us see here. Is number 1 less than number 2? 6 not less than number 4. That's why it's not going to go to right. It's going to go to bottom. Look at here. As you see, the liquid moves here. Is number 2 less than number 3? Yes or no? Number 2 less than number 3? Yes. 4 less than 5. Then, because it's yes, it's going to move this side, and minimum is going to be number 2. Like this, minimum is going to be number 2. And then this liquid goes to min. Minimum is going to be shown on the screen, which is 4. And program ends. Liquid comes to end. As you see, program is working properly. Like this, you can stop the video, and then you can try the other possibilities. Of course, not clicking with your pen or pencil. You can think, enter some other numbers. I prepared for you for a while. Here are the examples. For example, for number 1, number 2, number 3, I pressed 1, 2, 3. Or I entered 1, 2, 3, or 1, 3, 2, 2, 1, 3. 2, 3, 1, 3, 1, 2, 3, 2, 1. So what are they? All possibilities. Every single time result is going to be 1, of course, but sometime number 1 is 1, sometime number 2 is 1, sometime number 3 is 1. All those 6 possibilities. Try here yourself after pausing the video. Try here yourself, and according to this entrance 1, 2, 3. Is 1 less than number 2? Yes, come here. Is 1 less than number 3? Yes, and come here. Number 1 will be shown. So 1 is shown. The first line has been done. First column has been done. And the second column, and then third column, like this. Try yourself. Okay, let's carry on. I told you before in algorithm, my brain is working like this, and then this is my algorithm. This is my flow chart. It doesn't mean that it's the only correct way that you are doing for the flow chart for answering this question. So this is another one. As you see, another person can think about to find the minimum of the 3 numbers. Can be like this. So that's why for each problem there can be more than one solution. 2, 3, 4, 5, 10, 100, 1000. So there can be a lot of solution for each problem. Okay, so like this we have different examples. Here is a text, for example. Quickly, I'm going to just leave few seconds. You can pause and read yourself. And after that, for this text, first you can draw the graph. As you see, for the first part, from 0 to 60, you are just speeding up for 10 minutes. After 10 minutes, until 20 15 minutes, sorry, 10 plus 15, 25, yes, until 25. Until 25 your speed is without changing is going, and after 25 in 10 minutes until 35 your speed is slowing down. So this is how your speed goes up and goes continuously without changing, and then after that slow down, and then this is your graph. So we are not physician, we are not scientific person for the physics or the, that's why to make calculation about all those things is not easy for us. If you know it, is of course much better. If you don't know it, you can ask to any physics teacher or any scientific person, or you can ask some how do you say, search engines to find the solution. So what is that? The question was in t time, for example, in 20 minutes, for example, 20 minutes here, what is the speed? 60. In 30 minutes, or yeah, in 30 minutes, what is the speed? Is 30. In 10 minutes, what is the speed? Is 60. So in 5 minutes, what is the speed? Is 30. So how do I know this? Because it shows the graphic, and our eyes are just watching it, and our brain is saying that. But when it comes to formulation, when it comes to the task, so there are three places. The first place is here, the speeding up. The last place is to slowing down, and there is a constant part here. So that's why if your t, as you see, if your t greater than 10, less than 25, speed is 60. If it is less than 10, depending on your time, you must do calculation. If it is greater than 25, depending on your time, you must do calculation. What is the calculation? You can guess the calculation. For example, here is the important part. Pseudocode, human readable. T is times, V is speed at time t, kilometer per hour. So step 1, you are starting, you are getting input t, that was the question, and you are checking the t. If t less than 10, if t less than 10, what's going to happen? You are going to do calculation. What's that? Go to step 4. We will go to step 4. Otherwise, go to step 5. What does it mean? If it is not less than 10, if it is bigger than 10, then go to step 5. Let us check, is it correct? Yes. If it is less than 10, do something. If it is greater than 10, maybe this or this part. Okay. So that's why step 4 and step 5, two different steps. Step 4, what does it say? V is equal to 60. What does it mean? When you enter 5 times 6 is 30. So V is going to be 30. Is it correct? Yes. If it is 10 minutes 60, then 5 minutes is 30. Then 2.5 minutes is 15, for example. 4 minutes is 20. No, 4 minutes is 24. Anyway, this is the formulation. And then after you have done this number 4, step 4, you can go to step 8. We will see what step 8 is. Let us come back here. Otherwise, if it is less than 10, go to step 4. If it is greater than 10, you do something else, which is step 5. Let us go to step 5. What's that? If t is less than 25, go to step 6. Otherwise, go to step 7. If t is less than 25, let us look at here. If t is less than 25, it was greater than 10. Now it is less than 25. Velocity is, speed is 60. Let's see. Yes, v is equal to 60 for step 6. And then go to step 8. If t is not less than 25, then go to step 7. What is step 7? Here is step 7. It's saying that 210 minus 60. How do I know it? I don't need to know it, but at the end of the day, I just made some search and I did calculation and I found it. Whatever it is, doesn't matter. So it's a formula. And at the end, you are going to show the result, what the velocity is at a certain time, and program ends. Let us do some example, but by showing this flowchart. Here is start. Read t from the user, and then here it is t less than 10? If so, yes, look at here, there is a yes message here. If it is true, come here, v is equal to 60. If it is false, if t less than 25, if it is yes, come back here. If it is false, if v is going to be 210 minus 60, 210 minus 60. You see all those conditions is written here, and put your water here and read t. First you enter for the t, enter 5, enter 15, sorry, it was capital letter, that's why. T is equal to 5. Secondly, t is equal to 20, not 20, let's make it 15. And lastly, t is equal to 30, for example. Okay, for these three conditions, please run this flowchart. Okay, let me just show you here, and you will see the correct result all the time. For 5, you can pause the video now and just do calculation. For 5 is going to be here. For 15 is going to be here. For 30 is going to be here. And at the end, we are going to show the result. Okay, so as you see, this is another example. And I'm not going to spend time on this example, example 9, because you are going to determine triangle, equilateral, isosceles is nice word, I like it, or multilateral, lateral, when the lengths of each side are given for the triangle, and ABC are the lengths, output is going to be the type. And here is the algorithm. I set algorithm here. I can just write here pseudocode. Okay. So then after that you can read it, you can pause and read it yourself. And the next step is going to be our flowchart. So as you see, in condition all those things, you can see which kind of flowchart, which kind of triangle it is. And again, example 10. I'm not going to spend a lot of time here. You can just read through yourself, so you know how to calculate the real roots of the second order equation. As I mentioned to you before, we are not mathematicians, so that's why we don't need to know how to calculate it. But at the end of the day, we know, doesn't matter. It shows you the A, B, C are the coefficients, and outputs are the x1 and x2 are the roots. And then temporary variable, we need delta. Delta is equal to a square, square root of b square minus 4ac. And here is the algorithm, in other words pseudocode. It's written here. And after this pseudocode, this is our flowchart. As you see, you can pause all the time and then just watch and understand how it works. Okay. And then we have another example, as you see here. And then here is the algorithm that we created, and here is the flowchart that we have. And the next step, example 12, factorial n. This is a good one. Here is the algorithm, flowchart, pseudocode in other words. And this is the flowchart for this pseudocode. And this is the end of video. Thank you very much for listening. Please follow my next video, and as soon as I just take that video, I'm going to put on YouTube. I hope to see you again. Have a nice day.